YouTube. It says we've got a few people waiting for YouTube, which is kind of, that's good. All right, so it's not going to show anyone showing up until this feed loop wakes up. So, It says we've got a few people waiting, which is kind of, oh, weird. Good. And there was some delay there. That was bizarre. All right, so it's not going to show anyone showing up until this feed loop wakes up. So,
That's weird.
That I mean, you can still see me right now. It's not like everything is just, yeah, okay. Because I can see you fine. So it's just like there's a big delay here. That is weird. We might have to restart the stream. Not show anyone showing up. Yeah, that's not going to work.
So should I log off?
Yeah, I think maybe I'll shut everything down and try again. I mean, I don't have a better idea.
Okay, let's do that.
Okay, let's do that. I think maybe it was streaming in the background and that was the 10-second delay or something. Right. So let's restart the stream. There it is. Yeah, that's what it was doing there, I think. Okay, but it hasn't started here, so sorry about this.
Oh, no problem.
Let's see. Is it custom streaming? It says it's custom streaming. Okay. Let me see. I think we're live now. Okay, that's good. And now I'm seeing the participants we need to see. So my apologies to everyone there about the 3-minute delay here. We had some strange things going on. And I did see some people on YouTube had kind of figured out that there was an issue, I think. So it's great to see the attendees who've joined. I want to ask the attendees, since we have kind of a smaller group now, whether they're kind of interested in sharing their video if they have video, or turning on their microphone. I tell you what, this is what I'll do. I'm not going to put anyone exactly on the spot, but if you want to raise your hand, I think that's an option. Then you can just kind of be part of the conversation, because we don't need this webinar, which is going to scale to 1,000 people for 8 of us. We could just have a conversation. So if there is any attendee who, well, you need, if you've got the hardware to do that and you've got the interest to do that, then raise your hand and I'll promote you, but you don't have to if you don't want to. Okay. All right. We don't have any takers yet. Fine. It's a little like being called to the front of the class, I guess. So
it sure is.
Yeah, maybe it's a bigger class. It's the whole internet. If you weren't expecting to be broadcasting to the internet, who knows? Maybe you're in your underwear or something. I don't know. It could happen, right? So I do have some questions. Because I thought we were having kind of a very interesting conversation. We kind of ran out of time. We got a very nice question at the end, and you asked and you wrapped it up in time, because I guess you had an eye on the clock there. But one of the questions, just to kind of remind us, we were talking about this question of, there are a lot of things that you're saying would be better practices. You're saying, actually, I'm putting words in your mouth a little bit here, but as engineers, we need to raise our game and do a little better. And actually, one of the things I said at the end was, well, I don't know that that the decisions that I'm making as a roboticist in academia matter that much. And you basically said, don't wait until you think it matters. You need to start doing this now, because it's going to matter sooner than you think. And if we don't, as the community, start to take responsibility for this, someone is going to, and it will be a lawmaker or someone who will have the interests of the public in mind and is not going to have the technical background. And so, we need to take charge and be involved from the get-go. And then what was asked was, well, the person was saying, I'm a grad student and I've got all this pressure. I got to publish. And now you're telling me I got to go do all these other things. And you were saying, well, you can maybe recapitulate what you were saying a little bit.
Yeah, well, actually, I'm going to start with giving some examples of this. So, right now, facial recognition, emotion recognition is a really big thing. And, because they're like, oh, the accuracy rate is different for different groups, different demographics and things like that. And so think about this. If you look at facial recognition, back in the day when it was a research problem, what is it that we did? We collected images, we would share it, we would put it online. Right. And we really didn't think about representation. It was like we were just trying to figure out like what is an action unit? How do we actually do these points of the face and things like that? But yet we wanted to share with each other. And so we made these, corpus of data, we would put it online. I remember some of my early work, CMU had a right? And you would go there, they had all these images that were labeled and you train. And then what we found out is that companies, as they were developing, they were like, oh, these academics, they have data. Let's take their data and train our own algorithms. And then if you look at how these systems were deployed, it's no surprise because a lot of the theory that they were grounded in, the training that they were grounded in, was because of back in the day, the data sets we created that we were sharing in terms of open knowledge were also used for these deployed systems. And so that's one of the things is as researchers, we do have to worry about it because someone else may take it and not realize because we're academics and we're smart. So of course they must have done like all the things that are necessary. We're just borrowing, but we don't really think about these things.
And there's a really nice example there of something you kind of touched on where you said, once something is in industry, and then you recognize there's an issue, they have to pull the product off the market. That's the phrase you used. And they're not going to do that. Like, it's not like a couple of grad students who you write up, you put a notice on your little web page, your web page, which has a tilde in because it's your own personal little home page and it's got 50 hits in the whole history. And you say, by the way, there's an issue here. No, it's a completely different game there. And they're monetizing that and they've got people whose jobs, presumably, whose salaries are paid from that. And so, that's one of the things that I feel. There are a few cases where I visited factories where they work on automation, and I work on coordination algorithms, and I go there and I see how much freedom and flexibility we have, and then we take it for granted. It's actually kind of a type of a privilege that we don't kind of realize that if tomorrow I decide all out, we're not using those algorithms, we're going to use a whole new set of algorithms. We turn a switch and we do that.
It wouldn't even impact.
Yeah. So that was kind of something that I saw was that I kind of connected with your talk. I thought that's a really good. There are big ships with small rudders, I guess, since the Suez crisis. Maybe that's or maybe not the Suez crisis.
That's not a good example.
That's right. Yeah. That's exactly right. But it seems. It's a bit like someone asking, how do you solve an open-ended problem, or how do you future-proof something? It's hard because who can anticipate what's going to happen? And that's one thing that I saw in your talk compared to some other people's talks about similar related issues. As you said, you gave this example that we all have things which make us unique. So maybe it's the age or race or gender or some other unique characteristic, but we all have them. That's what makes us human. And the thing that I found very interesting is you said, and so the thing that we need a technique that when we discover there's a bias, then you go and address that, right? So what I really liked was this idea that like, you're not going to say, okay, we're done. What you're saying is that this is a process. And the process is we're going to discover something else. Discover something else. Yeah. And so this idea of kind of, and what I liked is that this was not just philosophy. You were saying that, when we do this, what you're proposing is we need a specialized learner for that. Then you bring in a specialized learner for that. And then you discover, oh, there's something else we didn't think about. Okay. Specialized learner for that as well. Right. And so I really like that point of view because it seems to address this question of, how do you future-proof? And you're saying you don't. It's sort of like cybersecurity. How do you make something secure against the future attacks? I don't know. I can't tell you.
You keep updating. You keep updating.
Yeah.
But this is funny because we do this. You know, you're an academic. I'm an academic. We do this with students all the time. And for those of you who are out there who are also academics, right? Like knowledge changes. If there's an instructor or a professor that's still teaching exactly the same knowledge that they were 20 years ago, well, first of all, that professor should probably not be teaching anymore, right? Because things change, you know, things adapt. Even an algorithm, like what is it that we do with an algorithm? It's 96% accurate. I know I can get it to 98%. And so we build on it and we expand it. And yet a lot of times when we're thinking about AI and machine learning and it's deployed, we don't think of it in the same way. Like, well, it's not going to be perfect. We need to improve it as we get more knowledge and we get understanding of, you know, what are the holes, what are the gaps.
Yeah. And actually it's again something which kind of reminds me of something Larry was talking about, because of the fact that they have these, and of course you're at JPL, you know this as well as anyone, but the RAD hardened processes are kind of like 15 years back. So he's straddling this weird thing where he is looking at these older things, but they kind of know what the next step is that they want. And it's exactly that. I mean, you were talking about this corpus of faces, and I was thinking of eigenfaces, right? That was what at the time was the big deal, right? I'm sure none of the cool kids these days know anything about that.
Pentland and Turk, I think. The Pentland and yes.
Yeah, that's right. Yeah, that's right. Yeah, exactly. So okay, so people from the audience, you should ask some questions, or we're just going to start reminiscing. We've already started, and so
we promise we won't say, you know, back in the day, 20 something years ago.
And to walk uphill both ways, or whatever the story is. So one of the things I do know, I know some of the names of the people who are our attendees, and I know that many of them are graduate students. And so perhaps I can try to ask a few questions sort of about maybe careers or career advice and picking research problems. And so one thing that really struck me from your talk was that, first of all, it was really interesting, because when you read a paper, the paper is very much the finished product, right? It tells you this whole story, and the paper always completely makes sense, because you've kind of got this, if you're like me, your life as a researcher is this tree with like branches everywhere. But then you get down to a leaf and you're like, oh, this is totally publishable. And you look back up the tree and it traces it all the way back up, because there's a tree. So there's one path back to the root, and it completely makes sense, right? And we touched on this a little before earlier, where we were talking about sort of the negative results and your students reaching out to the authors and saying, what about this? And they say, oh yeah, we tried that doesn't work. And what I liked about that is, in your talk, is you kind of said, so we looked at the data, and then we were like, oh dear, well, what does this mean? The neutral robots, they all think they're male. Oh, well, that doesn't bode well for, but then you said, but we carried on, we kind of powered through. And you sort of had the faith of a researcher, or you were committed, I don't know, or a mechanical engineering term, you had the inertia, I guess, however you want to say it. And so there's to me, that's a sign of a fine researcher, is they know kind of which things to stick with their gut and which ones not to. And I don't get it right, but I feel like when I get a grad student, and I've had a grad student who did this, I said, I don't think it's a great idea. He carried on working on it. And, 2 years later, we wrote a DARS paper, and he was nominated for a best paper award on that. And I said, well, I wouldn't have guessed that, but that tells me that student's ready to graduate. Do you have kind of some advice? You obviously have kind of figured this out. So but
yeah, is there I will tell you, some of my students' best work is this, pushing forward. So there was one study, and it's actually infamous or famous, emergency evacuation, where we had basically deployed a robot in terms of an old abandoned building. And what we found was that people followed the guidance of the robot during an emergency evacuation, where we filled the room with smoke and things like that. And I will tell you the way that it came about was we had an hypothesis that we had done, and we had used simulation robots and things like that. And it showed in the simulation one thing. And so, of course, we then did the real world because now it's real people. And what happened was in our very first, hypothesis was like if the robot made a mistake, the humans wouldn't follow and things like that. And we did this and people followed the guidance of the robot. And we were like, oh, well, what's wrong? Like maybe it's the robot, maybe it's the, right? And so then we it kept on like, okay, well, let's figure this out. Well, let's add in different behaviors. Maybe they didn't understand the robot made a mistake, right? Like we were thinking about all these scenarios of why was our hypothesis wrong? Or, maybe they didn't realize they were in danger. Maybe they didn't see the exit sign. Maybe, and we just kept building and building and building, trying to basically validate our original hypothesis, which at the end of all of this, we realized that that original hypothesis was absolutely wrong, that people overtrust these robotic systems. And it was at the end, it's brilliant. I mean, people still talk about this study. It basically took my group down this whole.
Yep.
Yes, right. Yep. But it's because we kept pushing. It's like, oh, something's wrong. Let's keep. Okay, something's wrong. Let's keep. And then what we did is we then published the entire study with all of the enhancements. And well, this is the original hypothesis, and this is what we ended up. This aspect of overtrust. And so I think some of the most interesting things are when you examine and push through your assumptions that you think are correct, that are incorrect, and say, okay, this is a mistake, because at some point, maybe it's not a mistake. Maybe it really is truth. It's just you have to rephrase and rethink what it is that you're assuming.
Yeah, no, I buy that. And that's an excellent example of that. Actually, I didn't know that whole background story on that. And yeah. And okay, now we've got a couple of questions that have come in. I could say more about that, but let me read first of all Caitlin's question. I think that's forgive me if I don't get the pronunciation right. The question is, I have a question about the topic of using a specialized learner to improve performance when an issue is found. Is there any approach that could be used to identify some bias in results without prior knowledge of a specific group or label or category to use as a hypothesis?
So I'm gonna say yes or no. So you still have to have some samples that belong to different types of groups. Maybe you don't know there's bias, maybe it's a small sample, because you have to basically be able to identify that there is some differences in accuracy or disparate impact or differences in results. So you do have to have some data. It may not be in the learning, but at least in the assessment. And so that's the no part. But the this aspect of, can you train it? I think yes. I think you can train even if you don't have a specific label, because one of the things, and we've tried to do this, if you look at the characteristics of what we call anomalies, and so we all do it, right? If you graph the accuracy, there's always this data that we're like, oh, this is anomalous, right? It's outside of the norm. And what do we do? Because it's like 10% of the samples, we throw it away, right? We say it's anomalous and it doesn't impact. And in fact, even, right, it's an outlier. I actually think that the outliers have value. And so creating a system where you look at the outliers. And so given that we work with children with special needs, a lot of our kids end up being outliers. And so if you instead focus on outliers when you're looking at your accuracy, like, what is this? What we find is that there's some interesting characteristics. And if you can look at why they're outliers, not just discard them, but actually look and see, is there something that's different about this outlier? It actually gives you an indication of the fact that maybe you can train or retrain or create a specialized learner based on this concept of outliers, because they're really not anomalies. Yeah, they really are data that you might have missed.
I like that distinction. They're outliers, but they're not other. They have structure. It's just not structure, which is the nominal structure, perhaps, or the majority structure, even, is perhaps
Correct.
So, yeah, correct. I think that's a great answer. Caitlin, are you happy with that answer? The second question. Okay, so we have another question, but I'm gonna follow on as if we were having one person who had the microphone, and then we'll hand it on. So I haven't forgot this other question. So Caitlin's question was, so first of all, response was yes, that was an answer, thank you. But the second question they had was about using humanoid robots to help students with cerebral palsy, CP. Has there been any follow-on work that has looked at whether some of the measured benefits were due to removing smells or noises or other distractions from the learning environment?
So we have, I won't say removal, but addition. And it's not with the humanoid robot. So we've done a new study and just accepted to IROS. So I won't kind of break all of the things, but yes, right, it's coming up. But what we are doing with that is creating mobile robots for, basically a mobile robot for infants. And in that regard, what we're looking at is we're coupling movement with sound, and movement, sound, and lights to try to figure out, are there sensory information that can evoke kicking behavior. So we're still trying to exercise, but it's with kicking, and it's using those three. And so with that one, it is a fact of, I won't say removal, but we're adding and trying to figure out what is the ideal kind of, is it movement? Is it lights? Is it sound? And just so you know, it's also personalized. What we found out was that every infant actually has their preference of what motivates them to exercise. And it's not just a one size, like, oh, it's always going to be, movement at this rate. Is actually preferred. And we can learn that, though. That's the key. We can actually learn that preference. Yeah, so.
That kind of explains, why, occasionally I visit someone who has an infant, bring them a toy. Sometimes you hit the jackpot and it's the favorite toy, and sometimes they don't care.
Yeah, it's a preference. It's a preference.
No, that's very interesting. And also, I had never thought about a robot for an infant, pre-2-year-old, because it reminds me of this work on the huggable robots, which I thought were really interesting, a new modality. But you guys could work on the first chewable robot. I mean, are there chewable robots? I mean, that seems like a whole new haptic interface, which could be kind of fun. Yeah, interesting. So thank you. Excellent question and great answer. Let me ask Somaya's question here. And the question is, it's also about learning. Do you think one-shot or few-shot learning can contribute to preventing bias in AI models?
I won't say prevent, I won't say prevent, but I would say mitigate. So basically, when I say prevent, I don't think anything prevents it. I think all AI, just like humans, are going to have some aspect of bias. But can you employ methods that help mitigate, so reduce the potential of bias? I think so. So the only problem I would say is, so with one-shot methods, it's going to be based on the data, right? It's going to be based on what is it that you're trying to learn. It's going to be based on what are the different attributes. Is there intersectionality, or is it just one thing that you're learning? That's actually interesting. We haven't tried that.
Well, there you go. That's a good sign of a good question, right? If it stokes the thought. So I think the audience is getting warmed up now, because we've got a question here from Matthew Strong, or Matt Strong, I think you go by Matt, right? When I've seen you walking around the Gather Town space. And it says, he said, in your talk, you were talking about how robots shouldn't be biased by social constructs. On the other side, how can robots potentially help eliminate the biases that we as humans implicitly have? So this is a little like a question we had earlier, and it's a great question. So, what are your thoughts?
No, it's a beautiful question. And so this was another paper that just got Best Paper Award by one of my other students at RSO. So we were able to show that bias typically occurs in a lot of cases is when you're uncertain about the data, or you're uncertain about the group. And that's really what happens is that the human aspect uses associations, uses lived experience, and bias is most apparent when you are uncertain about. So if I see, I'm used to seeing female nurses, a male nurse comes in, I haven't interacted with male nurses. So my uncertainty about what is my behaviors, what are the interactions, because I hadn't seen it before, then that's where the most bias happens. So that's, if you look at the social sciences, that's some of this aspect. And so we are able to show that when you have AI that is interjected, when we can recognize your uncertainty, it can, one, improve the collection of your data. So we did this with coders that were coding data for facial recognition algorithms, but it also helps them retrain their biases out. So it teaches them how to reduce their biases because the AI provides this information that says, hey, we know you're uncertain. We can see it because you're not doing this right. Coders can retrain. And so it's aspect of priming, but we can use AI to do this. Now, caveat, we only did it across gender, but we were able to show that it works for gender recognition when we're doing coding data, male versus female, female versus female, female, male, and so on.
Oh, there are a bunch of questions I would ask to follow up there, but I'm not going to, because there's another question from Kaiten actually, who's asking about potential for long-term studies, I think is how I'm reading this. The question is, are you storing that preference or value data in a way that could be used for future studies? It seems like it would be a really great data source to trend future development of events in those children. So I think we're talking about, this is in reference to the mobile robot, I think.
Oh, yes, we are. So our longest long-term study, right? Because we're talking about infants, so they grow up really, really, really fast. Is we have, well, they do. So we have a couple of infants where, and these are actually preemies. So our earliest infant is 3 weeks. And we've been able to track some of them all the way up until they are about to roll over. So about 6 months. So in terms of infant, and it's usually, we try to get a session once a month. So that's our longest term study with infants. And we do store values. And what we see, just so you know, because this is what we want to see, is that their preferences change, which is actually what we want to see. And we also have some higher at-risk infants where their preferences doesn't change as much, which is also an indication that.
So there's potential for diagnosis even there.
Yes, yes. And that's really the point. It's to do both intervention and diagnosis as before you can even really have them go to therapy.
Yeah, and that is a very, I mean, I never thought about that as a human population before, but that's got all sorts of challenges. I mean, you say like their learning rate is, off the charts compared to old folks, a year or older, old folks, but yeah, that's really interesting. It's almost like you reach into a point where you're challenging the stationarity assumptions, I guess, in them as learners, which is really.
You are right? Like there's an assumption a lot of times in these algorithms that, there's going to be no change in the dynamics, no change in the behavior over a certain time period. And that is not the case. In fact, even depending on the time of day,
wow,
sometimes their preferences change. So,
yeah. Well, yeah, I would say my preferences change over the time of day as well. You catch me a bit before lunchtime, but it's a bit after lunchtime.
Same thing. I'm sleepy, I'm hungry, right? It's just the same thing.
Yeah. That's what terrifies me, is we'll realize that we're not that far from just infants. Well, or maybe that's the flip side of that, is that infants are a lot smarter than we think. So yeah. So I can't believe it. We're out of time. This felt like a 5-minute conversation here, but part of that has got to go to the credit of the audience. So first of all, thank you guys for sticking around. I know I couldn't convince any of you to turn on your video and join us, and that's just fine. I'll try that trick again next week, since some of these are names that I recognize from last night. So thank you all, and it's great. A smaller crowd that's more engaged, it's so much the better, rather than 50 blank faces, 50 blank icons. I can't even see faces. And thank you, Ayanna, for making the time. And it's getting pretty late, your side of the world already, and so thank you for joining us and making this weird demand for me to say, could you do this before and after? You know, a very strange thing. And you just said, sure, you'd happily do it.
It
So
works. It worked. It worked.
thank you.
Awesome.
All right.
We'll see you next time.
Yeah. Take care. Bye.